In the competitive landscape of modern operating systems, security has become the defining battleground where consumer trust is won or lost. Windows continues to dominate desktop computing despite decades of malware and ransomware attacks that have cost businesses billions of dollars. Apple's Mac OS has successfully marketed itself as inherently secure through careful ecosystem control and hardware integration. Meanwhile, Linux maintains its reputation for robust security through open-source transparency and community-driven development. Among this established hierarchy sits ChromeOS, Google's revolutionary cloud-first operating system that stripped away traditional complexity in favor of sandboxing, verified boot sequences, and radical simplicity. From this foundation emerges FydeOS, a compelling and controversial fork of ChromiumOS that has quietly assembled its own dedicated following across global markets. Born from Chinese innovation under the guidance of Fyde Innovations and now headquartered in London, FydeOS presents itself as a privacy-conscious, cross-platform, enterprise-ready operating system designed for the modern web-centric world. However, its position at the convergence of ChromeOS's proven architecture, open-source transparency ideals, and Chinese corporate origins has sparked an entirely different security discourse than its American counterpart faces. This comprehensive examination explores FydeOS across multiple dimensions, investigating how it inherits and builds upon ChromeOS's security foundation, analyzing the unique protections it introduces, examining persistent concerns surrounding its ownership structure and proprietary components, and evaluating how recent security vulnerabilities have tested its reputation in the marketplace. Throughout this analysis, we will examine the layered defense mechanisms that define its security model and assess its suitability for various use cases. The foundational DNA, ChromiumOS heritage. FydeOS represents a sophisticated evolution of ChromiumOS, the open-source project that serves as the foundation for Google's ChromeOS. This heritage means FydeOS inherits the fundamental architectural principles that have made ChromeOS a security standout in the operating system landscape. The core design philosophy revolves around stateless system partitions where essential operating system files remain read-only, creating an environment where system-level tampering becomes extraordinarily difficult for malicious actors to achieve. The verified boot process represents another critical inheritance from ChromiumOS. Every boot sequence systematically checks cryptographic signatures to ensure that system files have not been modified since the last verified state. This creates a chain of trust from the hardware level through the kernel and into user space, making persistent rootkits and boot-level malware nearly impossible to establish. Automatic updates occur seamlessly in the background through an elegant A/B partitioning system that eliminates the traditional Windows-style update anxiety. When updates install on an inactive partition while the system continues running, users experience no downtime, and failed updates automatically trigger rollbacks to the previous working configuration. Application sandboxing forms the final pillar of this inherited security model. Each application executes within its own isolated process space, preventing cross-contamination between applications and limiting the potential damage from compromised software. This architectural decision fundamentally changes the threat landscape compared to traditional operating systems where applications share system resources more freely. Where ChromeOS maintains tight integration with Google's ecosystem of services, FydeOS deliberately embraces flexibility. Users can create local accounts that operate independently of any cloud service, integrate with Microsoft accounts for enterprise environments, or optionally connect to Google services when desired. This flexibility extends to application support, encompassing Android applications, Linux applications, and even Windows virtualization capabilities, making FydeOS particularly appealing to enterprise users and technical enthusiasts who require broader compatibility. Security architecture by design. The security by design philosophy permeates every aspect of FydeOS, creating multiple layers of protection that work synergistically rather than as isolated features. The sandboxing mechanism ensures that web applications, Linux applications, and Android containers operate in complete isolation from one another. When malware successfully compromises one application, it cannot propagate to other parts of the system or access data belonging to different applications. Verified boot extends beyond simple integrity checking to create a comprehensive trust verification system. If any component of the operating system partition shows evidence of tampering, the system automatically detects the compromise and initiates recovery procedures that restore the system to a known good state. This capability makes persistent malware installations extremely difficult to achieve and maintain. The read-only partition strategy prevents both malware and rootkits from embedding themselves permanently within the system. Unlike traditional operating systems where malicious software can modify system files and persist across reboots, FydeOS's architecture makes such persistent infections essentially impossible through its fundamental design rather than through reactive security measures. Comprehensive built-in protections. FydeOS implements file system integrity through DM Verity, a sophisticated kernel-level feature that continuously validates storage blocks against cryptographic hashes. When any block shows evidence of alteration, the system immediately rejects it, preventing corrupted or malicious data from executing. This creates a self-healing file system that maintains integrity even under direct attack. User data encryption represents another fundamental protection layer, with all personal information encrypted and cryptographically tied to user login credentials. This approach ensures that even physical theft of a device cannot compromise user data without the correct authentication keys. The encryption implementation uses industry-standard algorithms and follows established best practices for key management and storage. Rather than relying on traditional antivirus software like Windows systems, FydeOS leverages its architectural advantages for malware protection. The combination of sandboxing and verified boot creates an environment where malware must simultaneously break multiple independent security layers to achieve persistence. While no system can claim complete immunity to malware, FydeOS's approach makes successful infections significantly more difficult and less damaging when they occur. Account management in FydeOS provides administrators with granular control over user permissions and system access. Local accounts can operate completely independently of external services, while enterprise deployments can leverage FydeOS Management Cloud for centralized policy enforcement, update management, and device restriction controls. Advanced biometric security implementation. FydeOS distinguishes itself in the biometric security space through its sophisticated approach to fingerprint authentication that prioritizes local processing and hardware-level protection. Unlike many competing systems that enhance biometric matching through cloud-based processing, FydeOS maintains a strict local-only storage model that never synchronizes biometric data with remote servers. The fingerprint data encryption utilizes advanced encryption standard algorithms combined with hardware security module binding that ties biometric information directly to specific device hardware. This approach ensures that even if someone gained access to encrypted fingerprint data, they could not use it on different hardware without the corresponding security keys. Each authentication process flows through dedicated secure processes that operate independently of the main system, preventing tampering attempts and ensuring that biometric verification cannot be bypassed through software exploits. The system employs hash-based message authentication code validation to guarantee that stored fingerprint templates cannot be substituted or modified without detection. This implementation philosophy mirrors the security models employed by Apple's Secure Enclave and Google's Titan security chips, providing users with confidence that their biometric data remains protected from both external attackers and the operating system vendor itself. Robust update and system integrity mechanisms. The update mechanism in FydeOS represents one of its strongest defensive capabilities, building upon ChromeOS's proven dual partition approach while adding enterprise-focused enhancements. Updates install silently in the background on an inactive system partition while users continue their normal activities without interruption or performance degradation. Upon restart, the system seamlessly switches to the updated partition, and rigorous integrity checks verify that all components loaded correctly and maintain their cryptographic signatures. Should any component fail verification or cause system instability, automatic rollback procedures restore the previous working configuration without user intervention or data loss. This approach eliminates the traditional security vulnerability window that affects other operating systems during update installation. Users cannot defer critical security updates, and administrators cannot create network-wide vulnerabilities through delayed patch deployment. The system maintains continuous protection while ensuring that security improvements deploy rapidly across entire organizations. For enterprise environments, this update model provides predictability and reliability that traditional systems cannot match. Fleet-wide update failures become impossible because each device verifies its own update success and maintains its own fallback capability. Flexible account models and privacy considerations. FydeOS addresses privacy concerns through its flexible account model that provides alternatives to mandatory cloud service integration. Local accounts operate entirely on the device without any external communication, creating a completely private computing environment for users who prioritize data sovereignty. Fyde accounts represent a proprietary account system managed by Fyde Innovations that provides synchronization and backup services similar to Microsoft accounts while maintaining independence from Google's data collection practices. These accounts enable cross-device synchronization for users who desire cloud integration without Google's extensive data profiling. Google account integration remains available as an optional feature for users who prefer ChromeOS-like functionality and are comfortable with Google's privacy policies and data handling practices. This flexibility allows organizations to choose the privacy model that best aligns with their security requirements and regulatory obligations. The privacy implications of these choices vary significantly. Local accounts provide maximum privacy but sacrifice convenience features like automatic backup and cross-device synchronization. Fyde accounts require trust in a company with connections to both China and the United Kingdom, raising questions for privacy-conscious users about data handling practices and potential government access requirements. Transparency challenges and open-source components. FydeOS operates as a hybrid open-source and proprietary system, creating both opportunities and challenges for security-conscious users. The foundation remains the open-source ChromiumOS codebase, which benefits from extensive community review and transparent development processes. However, FydeOS adds proprietary enhancements for Android application support, Windows virtualization capabilities, and enterprise management tools that cannot be independently audited. To address transparency concerns, the development team maintains OpenFyde, a completely open-source branch that excludes all proprietary components. This approach mirrors the relationship between Red Hat Enterprise Linux and Fedora, where one version provides enterprise features with some closed components while the other offers complete transparency for community review. This dual approach creates a challenging trust calculus for potential users. Organizations requiring complete transparency can deploy OpenFyde and sacrifice some functionality for auditability. Those needing full FydeOS capabilities must accept some proprietary components and trust the development team's security practices. The transparency challenge becomes particularly acute given the geopolitical tensions surrounding Chinese technology companies and concerns about potential government influence or surveillance capabilities embedded within proprietary components. Addressing concerns and community skepticism. Despite its technical merits, FydeOS faces persistent skepticism from portions of the technology community, particularly regarding its Chinese origins and corporate structure. Many potential users express concerns about possible government influence, mandatory data collection, or surveillance capabilities hidden within proprietary components. Community discussions on platforms like Reddit reveal ongoing debates about the trustworthiness of FydeOS, with some users describing concerns about potential spyware functionality. However, extensive community testing and analysis have failed to identify evidence supporting these claims, and the company has consistently addressed questions about its data handling practices. The closed-source components represent a particular challenge for security-conscious users who prefer systems where every line of code can be independently audited. While ChromiumOS itself benefits from open-source transparency, FydeOS's proprietary additions create opacity that some users find unacceptable for sensitive applications. These concerns reflect broader questions about technology supply chain security and the challenge of evaluating trust in an increasingly polarized geopolitical environment where technology companies become proxies for national security concerns. Security Incident Analysis, CVE 2024-25825. FydeOS faced its most significant security challenge in 2024 with the discovery of CVE 2024-25825, a vulnerability that revealed default or empty root passwords in the systems, etc. shadow file. This discovery sent shockwaves through the FydeOS community and raised serious questions about the development team's security practices and quality assurance procedures. The vulnerability represented a fundamental security failure that could potentially allow unauthorized administrative access to affected systems. Some security researchers initially speculated that the vulnerability might represent a deliberate backdoor rather than an accidental oversight, given its location in a critical system file. Fyde Innovations responded rapidly to the disclosure, releasing patches and providing detailed explanations that attributed the vulnerability to configuration errors during the build process rather than malicious intent. Independent security researchers who investigated the incident concluded that the evidence did not support theories of deliberate nation-state compromise, but the incident nevertheless damaged community trust. This episode highlighted the importance of rigorous security testing and quality assurance in operating system development. It also demonstrated how quickly security incidents can undermine years of reputation building, particularly for companies already facing skepticism about their origins and trustworthiness. The incident served as a wake-up call for both the development team and the user community about the importance of independent security auditing and the challenges of maintaining trust in a politically sensitive technology landscape. Competitive analysis and market positioning. When compared to ChromeOS Flex, FydeOS offers significantly broader application compatibility through its support for Linux applications, Android applications, and Windows virtualization. However, ChromeOS Flex benefits from Google's global reputation and extensive enterprise trust relationships that FydeOS has yet to establish. Against Windows, FydeOS demonstrates clear advantages in malware resistance and system integrity protection. The architectural differences make FydeOS inherently more resistant to the types of attacks that regularly compromise Windows systems. However, Windows maintains dominance in enterprise productivity software and legacy application compatibility that many organizations cannot abandon. Compared to Linux distributions, FydeOS provides a more user-friendly experience that requires less technical expertise for installation and maintenance. However, traditional Linux distributions offer greater transparency, customization options, and community control that appeal to security-conscious users and organizations. For privacy-focused individuals and organizations, FydeOS occupies a unique middle ground that provides more choice and flexibility than ChromeOS while offering better security than Windows, but with less transparency than pure Linux distributions. Enterprise applications and sensitive environments. FydeOS positions itself strategically for enterprise deployments through several key capabilities that address common organizational security requirements. Kiosk and shared device deployments benefit from comprehensive lockdown modes that minimize attack surfaces while maintaining necessary functionality for public-facing applications. Educational institutions find FydeOS attractive for its managed account capabilities, automatic update systems, and reduced malware risk compared to traditional desktop operating systems. The simplified management model reduces IT overhead while providing students and staff with secure computing environments. Enterprise deployments can leverage FydeOS Management Cloud for centralized administration that includes policy enforcement, remote update management, and comprehensive device tracking capabilities. This management model provides the control that enterprise administrators require while maintaining the security benefits of the underlying architecture. Organizations seeking alternatives to Google's ecosystem find FydeOS particularly appealing because it provides ChromeOS-like security and simplicity without mandatory integration with Google services or data collection practices. Future outlook and recommendations. FydeOS represents a fascinating case study in operating system security that demonstrates both the potential and the challenges of building trust in today's geopolitical environment. The technical implementation shows clear evidence of sophisticated security engineering that builds effectively upon ChromeOS's proven foundation while adding valuable flexibility and functionality. For everyday consumers, FydeOS likely provides superior security compared to Windows and comparable protection to ChromeOS while offering greater flexibility in account management and application compatibility. The risk profile for typical home users remains low, and the security benefits substantial. However, organizations in sensitive industries including defense contracting, government agencies, journalism, or financial services may find the Chinese corporate connections and proprietary components unacceptable for their risk tolerance and regulatory requirements. The path forward for FydeOS requires continued investment in transparency, security testing, and community engagement to build the trust necessary for broader adoption. The Open FydeOS project represents a positive step toward addressing transparency concerns, but broader acceptance will require sustained commitment to open development practices and security excellence. Ultimately, FydeOS demonstrates that effective security requires not only excellent technical implementation but also trust, transparency, and accountability that extends beyond code into corporate governance, international relations, and community engagement. The operating system succeeds technically while struggling with the broader challenges of establishing trust in an increasingly complex global technology landscape.